Hello, and welcome to Reactor, an R package for unit testing Shiny app reactivity. My name is Jonathan City. Motivation for this talk is to create the ability to diagnose and resolve cascading reactivity in Shiny applications, which is an integral part of good application development, preventing waste of resources and negative user experience. Cascading reactivity can be defined as different parts of an application triggering each other without the control of the intended development. Unit testing creates a framework that improves the collaboration across multiple developers and enables a way to track across varying scenarios that promotes safer production environment. This is commonly used in R package development to validate source code. In Shiny applications, the ability to diagnose and resolve reactivity problems through unit testing is lacking. The solution that is given here is a package that solves this issue by creating a new framework that adds reactivity expectations to unit testing in R. With this package, defensive development can be applied to Shiny applications to both plan and preserve reactivity with multiple developers working on an application in a production environment. It can be found in github.com/YaniCD Reactor. How does Reactor fit in with other packages? Currently, there aren't a lot of packages that can deal with unit testing in Shiny, and specifically testing the reactivity of Shiny applications. The two primary methods right now are using a package called Shiny Test, which checks the input changes properly and the UI behaves consistently. It integrates with teststat and integrates with continuous integration. Within Shiny itself, there's Test Server, which is a Shiny module that creates a testing environment to verify the reactive outputs are as expected. These packages work well for testing that reactivity has occurred and that the output is as expected, but they do not test the reactivity as creating problems within the app or second-order effects such as repetitive and cascading reactivity. What does the workflow of Reactor look like? It can be split into three major parts. First, there's serving the Shiny application nested with where am I calls via processX. So we start with the parent session that you have a Shiny app in. You create a child process which then hosts the Shiny app. Second, you want to send commands or drive the Shiny application from another session that is hosted by R Selenium that can control a headless browser. As the application is reacting to commands, where am I logs reactivity events. Third, once the pre-specified commands have completed, the where am I log file is used by expectations of reactivity in a teststat environment, closing the loop. The rest of the slides explain how Reactor workflow is used through a simple Shiny app. The app will have two UI elements, a numeric input that the user can manipulate, and a plot output showing a histogram that is conditional on the changes to that input. On the server side, we will add a new element for logging reactivity using the package where am I. Here you can see it within the Shiny app, nested in a reactive call. First you have Shiny observe, the render plot, and within that there's a where am I tag. Now I'll explain what this where am I tag does. Where am I is a package that logs the locations where commands in an R session were invoked in their source location. Within Shiny it's simple. As we saw before, you just put in a line of where you want it to be triggered on the server side. Every time your rendering application hits the line, it will print, in this case to the console with cat where, and indicate which line is being hit accompanied by a counter. The tag itself is to create multiple counters. So I can have for each reactive element that I want to track, I can add a new tag and it will manage for me the counters. Here we have an example of where am I in action. So as the app is initiated, we see that the render plot is triggered twice. And then once we manipulate the app, where am I is triggered again. Now that we have an app with where am I call in the server script, we need to run it in a child process. To do this, we use process X and use localhost port by default. Don't worry too much, Reactor takes care of this machinery for you, so you don't have to actually know what is going on under the hood. Communicating with the app. To interact with the application, this is running in a child process Reactor depends on rSelenium. When rSelenium is invoked, it opens an additional child process and a port on the local host to run the WebDriver. So you have two actions going on at the same time. rSelenium uses web drivers to manipulate the content on the web browser, and these web drivers have pre-built arguments in Reactor that help the user run them without needing to specify manually what is needed. So now we have two active child processes running at the same time. One is the WebDriver and one is the Shiny app, and they are communicating to each other. We use rSelenium commands and built-in Reactor functions that can simplify asynchronous pipelines. As a side note, Reactor works with cry much the same way as it would rSelenium, where cry is using Puppeteer instead of WebDrivers for Gecko or Chrome or Selenium itself, or Internet Explorer. More info can be found on the repository. To help simplify things, there's a function that is created called test_reactor that ties all these concepts together. So here we have driver commands that are put in the expression. They contain expressions to pass to the WebDriver, which is here. Test driver is the rSelenium piece that contains the rSelenium driver over here. So the driver commands are piped into the rSelenium, which then interact with the Shiny app. The Shiny app itself, with the argument specifying where the Shiny app is, where the file of the Shiny app is, and what port to use, is added through the process X args. That opens the Shiny app in a local host, and rSelenium is interacting with Shiny app server. Driver commands. rSelenium driver methods that query them and manipulate the Shiny app are placed in a quote to be evaluated at a later time. So here you can put anything you want to actually manipulate the app in order to log reactivity. So here there's two commands. I'll go over what Reactor wait means in a second, but here we are waiting for input element to be created. And second, we are manipulating the app with an execute script command. So here we are setting the input value to 500. The asynchronous call of wait will run the expression only if Shiny is not busy. This is a bit different from other implementations that use timeout in JavaScript and in Shiny test, in that the timer is built in and will manage for you the time needed to wait, so you don't have to worry about having a bad connection or different types of operating systems that can change the timeout that you need to set. So back to where am I? As you're driving the app, with our Selenium, there's a log file that's being updated by where am I and keeping a counter for each time it's triggered in the app. So here you're passing commands, the log file is being updated. So in the case of our app, when we first initialized it and it invalidates itself, line 15 is being triggered twice in a row in the app. Now, was this intended action we wanted when we developed the app, or is this wasting resources? Because as we scale up apps to be more complex, the more unintended reactivity that we have, the more time we wait and the more resources we're wasting because we're triggering the same routines over and over again, which can slow down the app a lot. So now we have a log file on disk that we can use to query expectations of the app reactivity. In the where am I log, that is going to be piped into unit testing. Reactor comes with its own set of expectations that are built for where am I outputs and can be used inside of a test stat environment. Using the where am I log output structure, we indicate the tag that we want to use, hist, and the expected counter value too. So here, when we run the test reactor, the output is the where am I log, and it was assigned to the hist counter. Using that, we can use the expectation of the count equals 2. If it's false, it's going to give you how many counts of reactivity were actually hit instead of the expected value. So our app can be labeled as a bad app because it's not doing what we intended or what we wanted it to do. Why wasn't it doing what we wanted it to do? Because we were using the wrong function for the observe. In the observe call, every time the app is invalidated, it goes through and invalidates also everything under the observe environment. What we want to do is replace observe with observe event and have it be conditional on input n. That way this chunk will only invalidate when input n changes. What does a test that structure look like? With Reactor, it's set up exactly as test that in the same subdirectories. The only difference is that the tests that you're going to run with the Reactor are going to be using the Reactor file name structure. This serves the purpose of making it simpler to isolate reactivity tests from other tests that may be in the package. The reactivity test can be called directly using test app. This way, if you're using a package such as Golem in order to create your app and maintain your app, you can test reactivity and the package itself in two different settings. So this is what unit testing reactivity actually looks like in real time. So once it's invoked, it's going to run reactivity on a good app, and then we're going to expect it to fail on the bad app. So here we actually have this, and it's telling us that reactivity count of 3 and not 2. So the unit testing is reacting as we expected. Finally, all this can be tied into continuous integration, such as GitHub Actions, into a workflow. And every time you commit a change to your Shiny app, the unit testing can be run on the reactivity of the app to see if anything got screwed up by a pull request or a commit that was created. This makes collaboration simpler for Shiny and makes the stability of the Shiny app as it develops more robust. This is what the output of the GitHub Actions looks like. It looks like just like you would run it in your console. And that's it. So go on and test your apps, and remember what Reactor gives you. It simplifies diagnosing reactivity in Shiny. It creates a framework to store and reproduce testing in Shiny apps and can be applied in continuous integration environments, creating safer Shiny app development practices for teams to collaborate. Thank you.